Today we're going to focus on ordering fractions and decimals. Our goal is to apply and extend previous understandings of fractions and decimals to implement order and comparisons. In other words, we're going to use what we've already learned in order to compare and order the fractions themselves. So our vocabulary that we need to remember for this lesson is the difference between a terminating decimal and a repeating decimal. So a terminating decimal, of course, terminating, ending, the quotient when a long division problem results in a remainder of 1. So, in other words, it doesn't repeat. An example of that, 3 75/100 is a terminating decimal. A repeating decimal is basically a decimal that goes on forever when you keep dividing. So the definition is a quotient when a long division problem results in one or more digits repeating without end. So an example of that would be the fraction 1/3. When we divide 1 by 3, we get a repeating decimal. It's 1.33333 forever. So what we do is we only focus on the number that repeats. In this case, it's one single 3. And we put this little line over it that tells the person that it's a repeating decimal. It goes on forever. So 3/10 repeating is the symbol. Go ahead and pause this video if you need extra time to copy down your vocabulary. So let's look at a first example, because we're going to need to know how to write fractions as decimals and decimals as fractions in order to compare them. So write the fractions as decimals. Well, remember that decimals are simply division problems. And there's a few different ways you can write them as decimals, but many students find the easiest way is to divide. So one thing to kind of remember is that a fraction kind of looks like a division sign, except for instead of having the 2 dots on the top and the bottom, it has numbers. So 5/8 is just 5 divided by 8. So we can, of course, use our knowledge of dividing decimals. 8 can't go into 5, so it gives us a 0. Then we have to add a decimal after the 5. And then we look at the 5 as 50. So we, of course, can see that 8 can go into 50 6 times, which gives us 48. So when we subtract, we, of course, have to borrow, and we get 2. Add another 0, because we can't have a remainder if it's a decimal. And, of course, 8 can go into 20. 2 times, and 2 times 8 is 16, again remainder of 4, so we have to add another 0, and we keep going until we have no more zeros. And 8 can go into 45 times, and now we have no remainder because 5 times 8 is 40. So my decimal for 5/8 is 625 thousandths. Now looking at 2 3/5. So that's using division. Another way of doing it is, of course, to, you can kind of convert it as a percent. So you could say that 5/8 is a quantity over 100. But we're really not going to focus and then use cross products and then move the decimal. So some students ask me, is that another way of doing that? And I say yes, but that's not going to be our focus today because that's actually going to come in a later lesson. So for those of you who already know how to do that, hold on, be patient, and practice your division for now. So 2 3/5. 2 is your whole number, so that's going to go before the decimal. So some of you might find it helpful just to write that reminder for you. And then 3/5 we can just divide. 3 divided by 5. So 3 divided by 5, again, a common mistake is students will write 5 divided by 3, and you can tell that it's wrong because you'll get a whole number and a decimal. And if that's the case, just remember, if it's a proper fraction, you should always have a 0 in front in your whole number place. So it should be 0 and whatever, tenths, hundredths, thousandths, etc. So in this case, I can tell because it's a proper fraction, I should have a 0 there, which I do. 5 can't go into 3, but it can go into 30 6 times. And 6 times 5 is 30. So I have no remainder. So 3/5 is equivalent to 6/10. And yes, some students say, well, can I just convert the fraction? 3/5, multiply it by 2, and get 6/10, and then I know how to write 6/10. That is another way of doing it. So that way will work. So those are both two ways of getting the same result. So what you need to do is say, okay, well 6/10 is my fraction part, so it's 2 and 6/10. So basically you have to add 2 plus your 6/10 to give you 2 and 6/10, which is the same as 2 and 3/5. So I hope this helps you writing your fractions as decimals. Now we're going to go on to the next step and have you write some fractions as decimals. Go ahead and take a minute to pause and write these fractions as decimals. Now notice that the first one is an improper fraction, so you know you're going to get a whole number and a decimal. The second one is a proper fraction, so you know you're only going to get a decimal with a 0 in the ones place. Okay, let's go over these. So 11/6 is the same as 11 divided by 6. 6 can go into 11 one time. 1 times 6 is 6, and then 11 minus 6 is 5. So I have a remainder, so I'm not making it 5/6 because I don't want it as a fraction. I want it to be a decimal. So I have to add a 0, add a decimal place, and bring it down. 6 can go into 50 8 times. 8 times 6 is 48. Remainder of 2. Add a 0. 6 can go into 20 3 times. And 3 times 6 is 18. I have another remainder of 2. So I notice, well, if I keep going, I'm always going to keep getting a remainder of 2. Have to add a 0, bring it down. That'll be 3. Again, it's going to go on forever. So instead of dividing for the rest of our lives, once we get to that repeating decimal, which is just one single 3, we write our line over it. So we have 11/6 equals 1 and 83 hundredths repeating in the hundredths place. So our 3 is repeating. That's what's called a repeating decimal. Now 14/15, we divide 14 by 15. And again, I should get a 0 in my whole number spot, which I do, because it's a proper fraction. If I didn't, then I would know that maybe I reversed my division. So 15 can't go into 14, and the difference between 15 and 14 is pretty high. So I know that because 15 times 10 is 150, of course, I know it's probably going to be a pretty high number up there. So I'm going to try 9. So 9 times 5 is 45. 9 times 1 plus 4 is 13. And then I need to borrow, and I get a remainder of 5. I have to add another 0. 15 can go into 50 3 times. 3 times 15 is 45. And what do I notice? I have another remainder of 5, and again, If I were to keep going, I'm always going to get 50. I'm always going to multiply by 3. I'm always going to get 45. I'm going to have to divide for the rest of my life. But luckily, mathematicians invented a symbol that can prevent us from dividing forever. To give us an exact answer, we again have a repeating decimal. So, 14/15 is equal to 0 and 93 hundredths repeating. So that was 2 examples of repeating decimals. The previous examples, of course, were terminating decimals. Let's move on. Now write the decimals as fractions. And if you know how to say fractions or decimals properly, it's easy to turn them into fractions. For example, 72 hundredths is simply 72 hundredths, 72 over 100. Another way of looking at it is whatever this number is, add an extra 0 to your 1. So we have 1 and 2 zeros here. Here we're going to have 1 and 3 zeros, but we do have a whole number. So we have 3 and 875 thousandths. So that's 1 with 3 zeros. Now I have fractions, but I need to make sure that they're in simplest form. So 72 over 100, you probably notice that 72 and 100 are both at least divisible by 2. You might notice that 72 is divisible by 8, but 100 isn't. So that means that, of course, 72 is divisible by 4, and 100 is divisible by 4. So that can help me reduce the fractions. So 72 divided by 4 is 18, and 100 divided by 4 is 25. So my fraction is 18/25 in simplest form. Now in my next example, my whole number is going to stay the same. I have 3 and then 875 over 1,000. Well, you notice that it's obviously divisible by 5, so if you wanted to start by dividing it by 5, you could. But most likely, most of you recognize that it's divisible by 25. 875 is divisible by 25. It actually is divisible by something higher, but I want to represent what most students will do in their problems. So if we divided these both by 25, well, 25 times 4 is 100, so 25 times 8 is 800. What I meant to say was times 4 times 8. And then 75 divided by 25 is 3. So that would give you 875 divided by 25 is 35. And 1,000 divided by 25, well, 100 divided by 25 would be 4, so 1,000 would be 40. So again, we have something that we know we can reduce again. And that's why I said I can recognize that it's divisible by 125, but a lot of students wouldn't see that right away. So I wanted to model the steps you would probably take, which are logical steps. So 35 and 40 both are divisible by 5. And remember, I have to divide the same number on the top and the bottom. And that would give us 7/8. 3 and 7/8 is equivalent to 3 and 875 thousandths. So that's writing decimals as fractions. Now let's look at a word problem example. Veterinarian. Angelica's cat gave birth to a litter of kittens. She took the kittens to the veterinarian for a checkup. The kittens' weights were recorded for their medical records. What is the order of the kittens from least to greatest in weight? So, kitten 1 we know is 5/6 of a pound. Kitten 2 is 2/5. Kitten 3 is 1/4. And kitten 4 is 3/8. There's a few tricks you can make in order to avoid dividing everything by the top number. So most likely you're going to have to divide 5/6. So 5 divided by 6, again this is a proper fraction, so I should get a 0 in my ones place. So we have 6 going into 50, which goes in 8 times, and hopefully, whoops, from previous answers, you noticed that we know we're going to get a repeating decimal. It's not repeating at the 8, though, it's repeating at the 3. So kitten 1 is 0.83 repeating pounds. 2/5. Now, 2/5, you can divide 2 by 5. However, a better time saver, and of course you would get 4/10. You could probably recognize that 2/5 equals 4/10, and you know how to write 4/10 as 4/10 using your place value. A quarter is another one where you could divide 1 by 4 and get 25 hundredths. But you also would notice probably that 1/4 of a dollar is 25 cents. So that's another one that you can really look at in 2 different ways to find the answer. Finally, you have 3/8, which is 3 divided by 8. And again, it's a proper fraction, so I should get a 0 in my ones, which I do, so that means I set it up right. Give me 6, 7, 56. It's going to give me a remainder of 4. So that gives us 375 thousandths. Now, another thing that I often encourage students to do is whatever your highest decimal is when you're comparing fractions, go that many places with all the rest of them. Because a lot of students will say, oh, well, my greatest number is 375 thousandths. Well, if you think of these as money, you would have 37 cents, you'd have 25 cents, and you'd have 40 cents. So in this case, we're going to go 3 decimal places. Remember, here I shouldn't put a 0, I should put another 3. So this just makes it easier for me to compare. It's another way of writing these fractions. So I can see, well, my pounds from least to greatest is 1/4. So we have kitten 3. And I'm just going to put a symbol there. Then we have kitten 4, which is 3/8. Then we have kitten 2, which is 2/5. And finally, the largest cat is kitten 1, which is 5/6. So those are my weights from least to greatest. So I hope that helps you comparing and ordering fractions and decimals. So in this trick, we just transferred them all to decimals. In previous lessons, we found the lowest common denominator. Well, if you found the lowest common denominator between 4, 5, 6, and 8, it would be a pretty high number. So in this case, decimals is much more makes much more sense, and it'll probably save you more time. Okay, so now we're going to use models to compare a fraction and a decimal. So looking at 7/10, I can display this, of course, as each one of these squares represents one whole. Rectangles, I should say. And if I break up the first one into tenths, I would get 7/10. So I can just say, okay, well, 10 pieces. So I can just break it up into tenths. So now I have 10 pieces, and I can shade in 7. So I have 1, 2, 3, 4, 5, 6, 7. Now for my second one, I'm going to look at 3/5, and I'm going to draw horizontal lines. So now I have 5 pieces, and I can shade in 3 of them. I could have done it vertically and then divided them into 2s and gotten a lowest common denominator, but in this case I want to show you ways that you can compare the two in an alternative way. So now what I'm going to do on the top is I'm going to do the same thing. I'm going to draw fifths, and then on the bottom I'm going to draw tenths. Again, keeping the same directions. Okay, so now I have 10 across, 10 vertical lines and 5 horizontal on both. So that gives me 10 times 5, which is 50. So now I have 50ths for both. Now I can just count up how many I have in each one. I have 5, 10, 15, 20, 25, 30, 35. And then I have 10, 20, 30, which is 30 50ths. So now I can see that 7/10 is greater than 3/5. So that's an alternative way of looking at fractions and decimals and comparing them, is to use models. So I hope that helps you for today. Now I want you to take a minute to pause the video and check your notes with my own. Make sure you have all the important information in the spaces provided. Go ahead and take a minute to pause the tutorial now. Another great job today doing your tutorials. I hope that you have previous knowledge that you found useful to apply to converting fractions to decimals, decimals to fractions, and comparing them effectively. So great job. You're doing a very good job on your hard work and dedication to your mathematical studies.